I hope that you are enjoying it as much as I have. And I consider myself to be a bit lucky to have seen the community and how it has grown over the past few years. So if you would please just join me with a quick round of applause to everyone in the community who made that possible. Thank you. A bit about me. My name is Abed Halawi, or as we call it back home in Arabic, Abed Halawi. I come from Lebanon, or as you may know it as the source of trouble in the Middle East, probably. But don't worry, I bring you no trouble today. I'm here to talk to you about the Lucid Architecture. It's a software architecture that we came up with at VineLab, where I work as a tech lead. Simply, as a tech lead, my responsibility is to make sure that the applications that we build are highly maintainable, and that whenever we go back to doing anything on that project, being an old project, not to think of it as a legacy application. So this Lucid Architecture will try to solve that problem for you, hopefully. Before I get to what Lucid is and how it works, I would like to have us all on the same page of what an architecture really is and why we should have it in our applications. So if I were to define it in very simple words, I would say an architecture is a pattern of connected structures. Well, these two words, structure and architecture, they come very often together sometimes. And before I dived into this realm of information and knowledge, they used to confuse me a little. So let's see them back to back. Let's see the difference between these both. And I would like to take a real-life example of our DNA structure. Well, this is what we call it, a structure, right? And what makes it a structure is the arrangement of these elements that make it what it is, an entity, or a construct, if you wish. And the connections that these elements make between these DNAs, different DNAs in our body, would make something much bigger. At some point, they made probably dinosaurs. So these connections have the value of the definition of what the outcome of these structures connected will make. Think of how we look like, for example, or the organs in our body and how they work in a coherent system that all works supportively, all made up of these DNAs connecting together. But enough with the biology talk, right? This is not a biology class. In programming, structures are basically the classes that we write. And we define them with certain properties that we give values to them, which will shape their characteristics. The values that these properties will hold will define what that class or the instance of that class really is. We can also manipulate these structures. That's something really, really nice to do. But of course, if that structure will allow it. Now, the connections that these structures make will end up being something more like an architecture. It is how these structures work together. It is how all of the system operates. It is as if you've zoomed out of your code and looked at your application from a top-level view to see how are these things working together and where they really reside in your application. Now, this is very important to notice that an architecture is also an expression of a viewpoint. So throughout this talk, you will notice that this is some kind of an opinionated way to do programming. It's an opinionated way to write code. But what makes Lucid a bit different is that it's been battle tested. We've been using it at VineLab for the last year and a half, used by 4 backend developers or maybe more, simultaneously on the same project. And the cool thing is that we never had to modify anything about what Lucid does. We just used it and we've been happy with it. So I hope that I could send that message to you today. So why would we have architectures in our applications? We've been doing it for almost decades now. And there are also architectures out there, so why a new one, right? So I'll mention 3 reasons why you would have an architecture. There are many. One of them is so that we can communicate structures. It is really important as teams. And again, we're talking about applications that scale, about code bases that would scale unmaintainably large. So it is important to be able to communicate these structures, how they work and how they operate among the team. And to have some sort of terminology that would define how these things work all together, especially when there are new people joining the team who would also get on board on the project. It makes it much easier to understand. Let me give you an example. If I were to say any of these words, a controller, a view, or a model, I'm pretty sure that everyone in the room would understand what I'm talking about, would understand the responsibility that each of these hold, and where they are in the application. But if I were to say a service, or domain, well, you've heard of these words. They're pretty common. We use them almost every time we talk about our code. But I'm quite sure as well that we got at least 50 different interpretations of what they really are and what they do and what the responsibility is according to the code that we write. And it's always kind of dependent on the use case. So it is important to set some sort of principles that would define what these will actually do and where we should have them in our code. Another reason is so that we can eradicate homelessness of code. I call it homelessness because about these codes that we really don't know where they should go in our code, where to put that piece of code. We shouldn't wonder. This is like a ground rule. We should not wonder where to put that piece of code. Where do we write that class? Where does it belong? And I would like to highlight these two bad boys in our code, the helper class and the utility class. These classes that we really don't know what their responsibility is, they violate every single aspect of the single responsibility, right? Because they are so vaguely named that you can stuff any kind of functionality right into it. So it's not predictable for you to just know, well, yeah, that goes in the helper class. Of course, that goes in the utility class. Because if you think about it, almost every class in our code is either a helper or a utility. Let me prove that to you. For example, our controller helps us handle requests, right? We delegate the requests to controller. Well, it is a helper. For a utility, well, let's think of the model, for example. It is a utility that we can use to manipulate and manage data in the database, manipulate the data records. Well, it is a utility. So these are vaguely named. And what's dangerous about these classes, most importantly, is that throughout the iterations of our code, as our code base is growing, the dependency for our code on these classes is growing. They're spreading through our code base. And at some point, it becomes really unmaintainable. And at some point, you would want to take that functionality outside, which makes it a little difficult. Now, one thing that Laravel does really, really nicely is this thing. You don't have such a helper class that helps you with everything. No, you have a string class, an str class, so you know whenever you want to manipulate, well, with a helper, you want to manipulate strings, you have the string class. So you go back to it and see everything that has to do with strings. And the same thing goes for arrays. You have an array class that does the same thing, but for arrays. So you know the responsibility of each class. Now, the last reason that I would like to mention is so that we can illustrate structures. It is really helpful to be able to describe our applications with this top-level view of how things are working. Let's take an example of the request-response lifecycle in Laravel and how it happens. Starting with a request, of course. It all starts with a request that goes to our HTTP kernel, where it turns that textual request into an object-oriented request. Well, so that we can manipulate it with object-oriented programming and treat it as an object, basically. And we can also define middleware so that we can intercept that request right there. Before they get to our routes, I like to think of routes as if they were doors where someone could open, do something, and leave with a result, basically. So we define these doors for them so that they can enter and leave. And there are two ways you can respond to a request or handle a request. One is when you define a closure. It is when you write all of your routes and your handling of the request within your routes file. You know, that function with a return right inside of it. This is one way to do it, and the other way is to delegate that controller. Delegate your request to a controller so that it can handle your requests. But basically, they're both doing the same thing. They're both trying to process and respond to a request. And this is where things start to get a little awkward, because we trust Laravel and everything else. We know it's been doing really well there, and we just take it for granted. But when it comes to after that step, whatever happens at the controller level is where the mess starts to happen. It is where we start having technical debt. It is where we start thinking of adopting these different designs and architectures for our application. Well, technical debt is about that code that we promised we would refactor at some point so that we can reuse among our code, but we never do. Or maybe it is the untested code as well. And it is this area where such things happen. Legacy code. Every time you try to change someone else's code, well, of course, legacy code is always someone else's code, right? No, that's not true. I've written legacy code myself. Not proud of it, of course, I'm ashamed. But, but we're here to solve that problem as well. So when I was writing some sort of an outline of what that architecture needs to be, what is that, the things that this architecture needs to do so that it solves the following problems. The first one on the list was no more legacy code. I no longer want to look at code and see legacy code. The second point was so that we can define terminology that we can use to exchange ideas, to simple terms. We're talking about terms that we use on a daily basis whenever we talk about our applications, but literally we never incorporate those terms within our code as being, I don't know, classes or something like that. It is all about the terminology. This architecture needs to be comprehensive. I need to be able to adopt any kind of patterns, any kind of design patterns that I want. I want to be able to write the code the way I would like to write it. I need no limitations. This architecture should not enforce me to do anything in terms of how I write my code. And of course, it's all about workarounds, so we never want to work around that architecture just because we have it, and of course, no limitations at all. Well, we all love how well designed Laravel is, and to create an architecture that would extend on that, it becomes a little challenging because you know, you want it to feel native to that framework. You want it to feel like an organic part of that framework, not just something from outside that we just stick there and work with. And to do that, it has to be, of course, simple, using simple terms, easy to understand, it has to be clear. Again, we're talking about people coming into our team and wanting to understand what that application does, what's implemented in there, right? Without having to go back and forth to the people who worked on that code base. And of course, not to deal with interruptions. But yet, we're talking about applications that scale. So it has to be sophisticated enough to handle the scale. And again, when we talk about scale and performance, there's always this kind of compromise, right, with design. Because if you think of it as a comparison, you have the design, you have a beautiful application, so beautiful that you would really love to work on. But at some point, you're not creating an imbalance with performance, because at some point, you're going to be creating some overhead, because you want to design the most beautiful application. But if you were to create the most performant application and switch that balance, what you have is an application that is performing beautifully and optimally, but the code is unreadable. You'll most probably forget what the code does the next day you write it. So what we try to achieve with Lucid is about the balance between those. It's beautiful design and well-performing. It is not the most performing architecture ever, and it's not the most beautiful architecture ever, probably, but it's all about the balance between these two. But how? How would you create such an architecture? And here comes Lucid. Let's start by defining what the Lucid term means by itself. It says it's expressed clearly and easy to understand, which I hope that by the end of this talk I would be able to deliver it to be well understood. Let's start with Lucid. Some of the components of Lucid are the following: feature, job, and service. Of course, you've used these words before, I'm pretty sure. Let's start with feature. What is a feature in Lucid? It is as you describe it in business. Just like you would say, well, I have this feature in my application. This is what a feature is. But think of it as a class in your code. You have a class of each feature in your code. For example, one of the projects that we worked on was a publishing platform. So I'll be using those examples throughout the talk. One of these classes that you have is create article feature, so our publishing platform can create articles, and the login user feature, so that we can log users in. Let's see where that fits within our diagram, where we left off with Laravel. So beyond the controller, this is where the feature will be. And the controller, all that it does is serve those features. That's all they have to do. You know how we've always imagined the thinnest controllers we can ever achieve? We always hear about MVC, we always hear about controllers having to be thin. But is that achievable? Well, this is what we try to do. And this is all that a controller have to do, just serve that feature. And as you can see, of course, it's extending a controller that we provide that serve method as a common functionality. And what we're doing is passing in this login user feature with two colons class. If you're not familiar with this syntax, what this does is put the fully qualified namespace with the class name all together as a string, pass it on to that method. Of course, you would have to import with a use statement at the top. So this is all that the controller have to do. Imagine all the controllers having, for each method, just one line of code. This is all you have to do. Now let's dive into the code of one of the features. This is how we dive into code. So starting at the top, nothing fancy, just extending a feature that would provide, again, common functionality. Now if you've written a job in Laravel, a job class, you must be familiar with the handle method. But if you're not, anyway, I'm going to explain it quickly. So the handle method is a method that is called automatically by the dispatcher. Now, what is that dispatcher? You see, that serve method that we were calling in the controller back then, what it was doing under the hood is calling Laravel's dispatcher so that it uses its magic to resolve the dependencies of that feature. What this provides to us at the controller level is so that our classes, well, the functions that we call the serve feature, doesn't grow unmaintainably as well, because we would have to deal with the dependencies of that feature. But with using the IOC, we will have it resolved. You can stuff all your dependencies right in the handle method and have them resolved for you. Then we move into how we run jobs in features. I didn't talk about jobs yet. Well, what a feature does is run jobs. Every job is a step in the accomplishment of that feature. Let's take a look at the job and what it does first, and then we go back to code. A job is, again, a class, similar to the jobs that you have in Laravel, that we have in Laravel. And it is responsible for only one thing. It does only one thing. It is one step. And it is responsible for the business logic of that, whatever it is trying to achieve. For example, back to that create article feature. To create an article, we have to do these 5 steps. First, we need to validate the article input. Then we generate a slug. Now, generating a slug is not as simple as replacing spaces with dashes. It's also about making sure that that slug is unique in the database so that we can treat it as if it were an identifier if we want to reference it back with that slug. Then we upload files to CDN. Well, if you have like media within that article, you would want to upload them to a CDN so that you can serve them from there for performance reasons. And then save that article and most probably respond with a JSON if you're building some sort of an API. And of course, we'll be returning that article job most probably. So what we do is create a job class for each step. And back to that diagram, this is how it would look like. The feature, and all it does is just run these jobs. So now we're able to illustrate what a feature is. We can call it the name of the feature and know what steps it needs to take so that you can achieve them. And that is not only an illustration, but it's also physically written in code. And you'll see that in a second. And again, we're still doing the same thing. We're processing and responding to requests. Back into code, the way where we left off. This is how we run a job. Basically, you would instantiate it, pass in whatever it needs to work, and call that run method, pass the instance to that run method. There's another way you can run jobs, which is this one, where you pass the name. It is similar to the serve method that you saw earlier. You pass in the name of the class, and then you pass an array of keys and values. And the dispatcher will handle translating that into the dependencies of that job. So our save article job needs a title, body, and a slug. Let's see how that looks like as well. So we would define the things that we need, that job needs to work in the constructor. So we have a title, slug, and a body. We set them on that class, and then the handle that is similar to that handle method, it will have its dependencies resolved. We will have whatever we need to do in that job right inside that handle method. Now, there's something that you might have or might not have noticed, is that the order of the parameters between the constructor and the dispatcher are not in sync. They're not the same. This is intentional. Just to tell you that it does not matter how you define them. And again, this is also a maintenance issue because while the code base is growing, these methods and the constructors are changing. You will have to replace the places of these parameters. And this is bug prone, really. You can get bugs just because of you changing the order of these parameters. So having such a privilege not to obey the order of these parameters as they are defined in the constructor is really powerful. Now we get to the service. Well, throughout my career, all the projects that I have worked with have had at least two parts to it. You have the website and you have the backend, where you can have administrative access and manipulate data and manage everything around that. And now with the trend of mobile devices consuming data through APIs and other services consuming our data through APIs as well, you get at least three services in your application, or three parts for your application. And this is what in Lucid is a service. So we have a service for the website, we have a service for the API, and for the backend. Now, service is literally like a sub-installation of Laravel, but it's not a sub-installation of Laravel. You will see that in a second. So if we were to separate these features and jobs into their services, this is how it would look like. We have the website, where we have the list articles feature. Now you see, between the website and the API, it sounds the same. It is the same class. No, it isn't. For each service, it will have its own set of features, because the way we would respond, if you look at the jobs of these features, the way we would respond on a website, we would respond with a view. But the way we would respond on an API, it is through JSON. So it is not the same. Which means that the feature is a property of the service. Even if they seem like being redundant, they're not. Because internally, they have different ways of doing things. So you will have to have features per service. Now, when it comes to jobs, it is different. Because the way if you look at the job in the blue, the way we would get published articles, it is the same. We're just fetching published articles from our database, right? It is not different from a service to another, which means jobs are interchangeable between features, and they can be the same. They can be used or reused as they are. So they're not property of the feature, and they're not property of the website, of the service. Where do they reside? Well, before I tell you that, let's see how would a service work within our illustration back to the request response lifecycle? So within the HTTP kernel, I mentioned a middleware. Well, this is one of them that would detect which service you're targeting from our application. And based on that, it would redirect you to the service that you're targeting. And of course, each service would have its own routes, controllers, and feature set. And these features will be the way it would do it, well, there are many different ways that you could do it. But I'm only mentioning two ways. One is when you do it through subdomains, like the API. You have api.example.com. So when it sees that subdomain being called, it would redirect you to the API service. Or you would have it as a prefix in your routes, like example.com/API. Now, all that the features will be doing is calling domains, which is where we keep the jobs. So the jobs are available for all of our services. We can interchange them between all of our services. And the features can also interchange these jobs between each others. So a domain would represent some sort of an entity that we manage with our code. And it is not a business entity. It is also that has to do with the technical entity. For example, if we were to replace our jobs within their corresponding domains, we would have the get publish articles job in the article domain, of course, and save article and validate article input all have to do with articles, so you would stuff them there. And of course, to upload files to a CDN, we will be managing our CDN. So it is the CDN domain that we're managing. And of course, to respond with JSON, we will be dealing with HTTP, so this is the domain that that job belongs to. Now let's go a little higher in the illustration and see how these things connect together from a top-level view. Again, these are the layers that Lucid involves. You have the services implementing features, and those features calling jobs interchangeably, regardless of where they are and which domain. And there's still one thing that we haven't covered yet with Lucid, which is crucial to every application, really, which is data. Well, when it comes to data, there's nothing specific that Lucid does, really. Because data is most often a use case driven kind of thing where you cannot have something preset for that. So all we provide with Lucid is just a folder where you can put all of your models, your repositories, if you're using repositories. And of course, if you have these data-heavy algorithms or anything that you're doing to process data, you would have it like value objects and stuff like that. You would have it in your data. Now, let me touch back on the principles of Lucid. Controllers serve features, and this is all that they do. There's nothing else that they do. They shouldn't. And each method in the controller will serve one feature only. We should avoid cross-domain communication. Domains do not know about the existence of each other. They should not have any dependency between each others. So they are, you can think of them as isolated in your application. You have that domain, it has its own jobs, it does its own thing. It has nothing to do with anything else from the outside world. So is the same for jobs. Because what we're trying to achieve here is a place where you can look at the feature and see the steps that are being called. And if a job would be internally calling another job, this is unpredictable behavior. If you just look at it, you wouldn't notice that, well, that job must be calling that other job. So what we do is not have jobs calling any other job. So if you remember that job that the save article job, where we specify title, slug, and body, it does not care. I, as a job, do not care about how you got that information. Maybe you got it from another job or maybe from space. I don't care. I need it to work, right? Just get that information from me so that I can do my job. This is all that a job does. Before closing on the talk, Let me just tell you how you can get started with using Lucid right now. You would initialize a project with Composer Create Project, Lucid Arch short for Lucid Architecture, /Laravel. It will give you an installation of Laravel 5.3, now that it is out yesterday. And you would name your project. Then you would have to scaffold a service, for example, the API service, generate a feature where you can, that project ships with a Lucid, as you've noticed, a Lucid command line interface where you can use so that you can generate services, features, and jobs. It does that for you so that you don't have to go through the hassle of creating these files and managing the file system yourself. All you have to do is fill in the handle methods, basically. Then you would generate a feature using the Lucid CLI, make feature, you would specify the service where you want that feature to go, and you name that feature. Again, what you do is generate a job, and you would specify the domain, the user domain, and the job name. One thing that I would like to demonstrate before closing is the Lucid console. So Lucid will ship with a console that looks just like this. Well, these are supposed to be colored, but it's because of the screen. But since Lucid is all about, just a second, let me, okay, maybe enlarge that a little. Okay. Since Lucid is all about performance and the way your code really is, the way it is structured, and what is inside your code, it ships with this kind of an insights dashboard that would tell you about your code and how it looks like. For example, it would tell you how much commented code you have and the logical lines of code that you have in your application. It will tell you a little about your structure, the structure of your application, how many classes you have, how many abstract and concreted them, the methods and how you're calling them, static, public, and non-public, and abstract methods. It will tell you also about the size of your code, the lines of code that you have, classes again, the class length, and the complexity of your code, how complex is the structure and design of your code, and of course about the dependencies, how it looks like in terms of attributes and methods, instances, etc., and everything that has to do global. Where there isn't such a thing where it is a good or bad insight. It depends on the use case and depends on what you want to try to achieve with your code. But this is just there so that it provides you with that insight. And you can explore the services, of course. Like here, I don't think you can see it. Can you guys in the back see it? Is it clear? Almost. How about now? It's gone. This is the most we can go. So yeah, you can, consider me a newcomer to that project. I would be able to explore these services, see what features they implement, and of course I can filter through them and get to see the code of that feature, just so that I can have a quick idea of what we're trying to achieve here, right? It's also running jobs, so maybe I would like to go and see the jobs and see how we do things here, like, for example, the article. And, well, for example, when I joined, someone told me, go and look at how we publish articles, for example. I can also search for that here. Publish. Publish article, that's a feature, and the other is a job. I will start with the feature to see the different steps. Well, this is what a feature would look like in real life. So what we do first is find that article, and then we validate article publishing input. Of course, because when you're publishing, you have to specify, for example, the date of the publishing and where you would like to publish it if you're managing multiple platforms, etc. So you would validate that input first, and then you would validate the article, whether it is valid for publishing or not. Maybe you have like minimal requirements so that you can publish that article, like it must have a cover photo, it must have some other things that you require. This is where you do that. And then we generate a short URL for it. Now that we're publishing that article, let's generate a short URL for that. Then we save the short URL for article. We just pass in the article and the URL that we just got. We convert date to UTC for some reason, and then publish article. Well, this is where we publish that article. And of course, we would record who published that article and when it was published and whether it is trending or not. And if it were published correctly, what we do is map that article for publishing. Well, you wouldn't want to expose all of the article object to everyone, right? What we do here, just map that into something we can publish, like a prettier form of that article object. And finally, we would create a response and store it here. And if it weren't published, we would create a response with JSON error that we can just return by the end of this feature. Yeah, I guess that's pretty much it. That's it. We have time for questions. I'm lucky to have finished early so that we can be first in the rows for the food, huh?
Okay. Is it possible to dispatch job inside the job? So, for example, to avoid dependencies, like can we, for example, generate hash for file name, and after we dispatch job, that will save the file on CDN using queues? So is that okay?
Of course. These jobs are exactly the same as the jobs that you would create in Laravel. So they are queuable. You can do async, like just run that job, let it run in the background, and just keep the sequence going. Exactly. You can do that, yes.
Okay, thanks.
Can you elaborate on the testability of this architecture?
On?
The testability.
The stability. Testability.
Testability.
Right. So what you will be testing is in two different ways. One is unit testing, where you test your features and jobs as classes as they are, and you would have functional testing where you would test all of the process, where the controller runs the feature, serves that feature, and to see the whole process. And the tests, let's say you have an article domain, you would have the tests folder within that domain. Maybe I can show you just quickly how a service looks like. Maybe that would give you a bit of an insight as well. For example, oh, you can't see that, can you? It's really small. I can't zoom in. But it's basically the domains here will have their own tests folder. So each job will have its own tests. Each domain will contain its own tests. Similarly, everything in the services will have its own tests as well, like features. You would have your features having their own tests as well. So completely, you can test everything. And with the upcoming version of Lucid, the generator will generate the tests for you as well, so that all you have to do is test the jobs as well.
Okay, great. Thank you.
Sure.
If you have a lot of if you have a separate feature or the same feature under every different service, isn't that duplicating a lot of code?
Most probably, when you creating two different services or any different services, the reason why you're creating them is that so that you can serve things differently, right? So that you can have different features. It might become redundant, but this is where we talked about compromise. At some point, you will have to compromise so that your application stays maintainable. Again, with large code bases, this is extremely important. So you would have to compromise not on performance, but kind of on the redundancy. But still, the jobs that these features will be running will most probably be different, because you must be doing something different there in a different service.
I saw in your code examples that sometimes you return result of job, yeah, and use it in the next job.
Yep.
And for example, if I made those job queuable and run test on my local machines, functional, and everything goes smooth because in test environment it's sync, and I push to production using Envoyer, and all tests go smooth because it's sync, and on production I have queues, and those returns will return nothing, and my production code will break down. How can we avoid this?
Well, in the first step, while creating that job, to be an asynchronous job, to be a queuable job, you wouldn't expect it to return for you, right? So you wouldn't have a variable that would be declared to hold that value so that you can pass it to the next job. It's usually synchronous jobs that we're running when we're waiting for a response or a return from that job. But when you're not expecting that return, you shouldn't expect it. So you should just run it.
How can we test it?
How would you test it?
Yeah,
well, it depends on how you would test a queuable job in Laravel. It's the same thing. So you'd have a queue running for your tests, and when you run, you would have a unit test for it, like mocking the realm of queuing, right?
Yeah, but queuable jobs, they usually tested isolated, so we do not expect them to return anything. And when like junior developers code, they do lots of mistakes. So in this case, you cannot really test that job will respond with something. So how?
Yeah, because you're not expecting the job to return something, so you wouldn't test it to return something. You would test the way you would test it normally,
okay,
with an isolation. So yeah, the test it is an isolated test for that job.
Hi, great talk, really interesting.
Thank you.
I had a question. Since your features are service specific, they seem to fill much the same role that a controller does. So I'm just wondering what the specific differences between a controller and a feature is in this architecture.
Right. Well, the way it's been designed, it's taken into consideration that the controller is supposed, as a responsibility, it's supposed to handle the request and not implement the feature itself. So the feature is what implements the feature. So whenever you want to look at a feature, you wouldn't go to a controller. You would find that feature class so that you can see how that feature works or the different step to achieve it. You wouldn't go to controller because this is not what a controller is supposed to do. This is basically the difference between them.
Okay, great, thanks.
Sure.
Is it possible to run a feature from the console, from a command, for example, a console command? Is that something that's built in?
Run a feature.
Yeah, so like the talk you were talking about from HTTP and running it through routes and stuff, but is it possible to run a feature from the console if you wanted to do that?
You would have to have a test that you would run so that it dispatches that feature. Oh yeah, and now I get to the question. Yeah, of course. If you were to create a command line, for example,
that's what I mean. Yeah.
Exactly. Yeah, definitely. This is actually something that we've done before. So you can dispatch features from anywhere in your code. This is one of the reasons why we have them. Very good question. From anywhere in the code, anything that can use what Laravel provides as the dispatches jobs, basically the trait. If you include it in any class, you would be able to dispatch a feature or a job in anywhere, not specifically to a controller.
Cool, okay, that's great, thanks.
Don't you think the validation step should be in the controllers because they are handling the requests? Because I saw that you put some validation in the features.
Yeah, well, we're making decisions on the principles, so you cannot have anything in the controller. Again, this is why I said first that it might sound a little opinionated. But again, we're doing that on the account of knowing what actually is happening in that feature. So if you were to visit that feature, you would want to know everything that that feature does and wouldn't have to switch between features, controllers, and routes maybe, or wherever you would go to find out what that feature actually does. Because you essentially want to learn about the system. If you want to learn, you would have one kind of central point where you would visit and find everything related to that there. This is why we have validation in there.
Okay, thanks.
Sure.
Hi, is there any way to convert an existing project to it, maybe partially first?
Yep, it's pretty easy to do so. We will have that in the documentation so that you can do it. But is there anything specific that you would like to know about?
No, I think that covers it. Thanks.
Okay, sure.
What would we, well, yeah, hi. Thanks for the talk, by the way.
Sure.
What would be the preferred method to handle failures in jobs? Would it be throwing an exception or returning false?
Exactly, throwing exceptions. You have this error handler globally provided by Laravel, where you can throw an exception from anywhere and catch it in the error handler. And in the error handler, according to another question here, we also call a job that responds with an error. So we have some kind of a unique way of responding to clients, and we define that within a job. So within our error handler, what we do is dispatch that job that returns that error, depending on which exception was thrown. So using those validation jobs, what they're doing is throwing exceptions, exactly.
All right, thanks.
Sure.
Kind of trying to see how this all fits into resource scalability. Like, would you run individual services on separate containers or machines?
Yeah, very good question. Actually, at the current time at VineLab, what we're doing is try to, with the trend of microservices, what we're doing is trying to get a migration path from having this monolith, which is something that you would start working with, until it grows so big that you would want to separate it into different services. And we're at the last stage of that. So supposedly very soon, you would hear about something that would help you turn these services into their own services, their own existence, and have them deployed on multiple services, or servers or containers, depending on your infrastructure. So totally, yes, you will be able to.
Right, thank you very much.
Sure.
I enjoyed your talk.
Thank you.